Hi, this deck of cards was compiled to facilitate working through MCAT standalone questions and passage-based questions dealing with average acceleration, average velocity, and average speed, and it's based on the physical foundations of biological systems concepts that the MCAT tests, specifically in translational motion with vectors and components. Average velocity is change in displacement or distance over time. So which is the correct answer choice? So repeat the answer down there. It's the change in displacement over time. And although average velocity is defined as the change in displacement over time, that's not really how you calculate it. You literally calculate it by just taking the averages of the velocities mentioned. So let's say that at 1 second, I'm traveling at 20 meters per second in my car. And then at second 2, I'm traveling at 40 meters per second. So the total time duration is 2 seconds. So that's going to be, in my denominator, but I'm not going to include the seconds, else I would be finding like some type of acceleration. Okay, so that's going to be 60 meters per second divided by 2. Therefore, my average of my velocities is 30 meters per second. Okay, that's an easy way to calculate it. What is the formula for average speed? So what is the expression for average speed? Meters in 2 seconds. Then my average speed, and speed again doesn't take into account any sort of direction. It's just telling you a magnitude, okay? My average speed is going to be 30 meters per second. And if you keep the first card in mind, the previous card, the average velocity was also 30 meters per second. So this is an instance where average velocity can be equivalent to average speed, but they're not the same thing. So don't get it confused, okay? Because I could have had, in the previous card, I had velocities of 20 meters per second and also 40 meters per second. So because I traveled at these velocities for 1 second each, that's why my average velocity worked out to 30 meters per second. But I could have traveled this much for like half a second and this much for like half a second as well. And the average, but my total, I don't know, it would just work out differently. Or actually, no, it wouldn't. Basically, it's not the same thing, okay? So just keep that in mind. The way you always decide what the value is for average velocity or speed is to do the actual calculation. Okay. Average acceleration is change in speed or velocity over time. So which one is the correct selection? So the answer is that average acceleration is the change in velocity over time, okay? And as an example, let's stick with traveling at a, a velocity of 20 meters per second in second one, and then traveling at a rate of 40 meters per second in second two. So the change in velocity here would just be the absolute value of the difference in the velocities, and that's going to basically equal 20 meters per second. And so our change in time, we're not going to consider the total time durations. Our change in time is simply going to also be the absolute value of the change in time, or the difference in time. So 1 minus 2 seconds is going to be negative 1 second, which is, I think, impossible, at least in the limitations of my mind it is. But the absolute value of negative 1 second is 1 second. Therefore, the average acceleration is going to be 20 meters per second. And just for clarity, divided by seconds. But for those of you who struggle with, dividing fractions by fractions, let's do a dimensional analysis on the units. And so, if you have meters per second divided by seconds, division is the same thing as multiplying by the inverse of the number under, or the value under consideration. In this case, it's not a numeric, it's an alpha, and that's second. So this would be the same thing as saying meters per second times 1 over second, or meters per second squared. So in every acceleration value you see, this is where the second squared comes from. So the final answer is 20 meters per second squared.